Hi class, today we are doing Unit 4, Day 4 notes, dilation, similar figures, perimeter, and area. So we're going to start with the fact you already know. Remember, when you dilate a shape, the image is either moving away or towards the center of dilation. As a result, your shape, if you are moving away, if you take a triangle, for example, and you are, the scale factor is greater than 1, it's moving away from the center of dilation, it is getting larger. Or if your dilation is going the other way, if you're moving towards the center of dilation, the shape is getting smaller. What's happening is the lengths of the corresponding sides are getting longer or shorter, which then results in your shape getting larger or smaller. All right, there is certain notation for dilations. Capital D stands for the word dilation. There are two subscripts. One of them will be a number, that's going to be your scale factor, and the other one's going to be a letter that is your center of dilation. Another way to write a dilation in notation is to give a coordinate and tell you what that coordinate is going to. You're going to recognize it's a dilation because you are multiplying both the x and y coordinate by the scale factor. And in this case, the scale factor was 3. So there's two different ways you could talk about a dilation in terms of notation. All right, so two very important facts here. Anytime you are identifying a dilation, you must also name the center of dilation and give it scale factor. So we're going to be coming back to that in a moment. And remember, dilations are not rigid motions. They do not keep the same size and shape. All right, so it turns out when a dilation occurs, similar figures are produced. And we talked about similar figures back in the unit when we first started talking about congruence, and we were looking at rigid motions. You guys defined what congruent meant and what you thought similar meant. And similar, we came up with same shape, different size. So a dilation is always creating similar figures. They're the same shape, just a different size. So similar figures, along with dilations, they have corresponding side lengths that are in proportion. We're going to start to use this word a lot. It means they were all multiplied by the same scale factor. That's what proportional means. All side lengths are multiplied by the same scale factor. And we know that the angle sizes never change. Corresponding angles are always congruent. So corresponding sides are going to be proportional. Corresponding angles are going to be congruent. All right, so we have a symbol now for similar. So if we have triangle ABC and you just have that squiggle, it's the top of the congruent sign, that means similar. So remember when we were proving triangles were congruent, we would always make the list. For this unit, when we're talking about similar triangles, this is going to be our list. So if you look at this picture, I have triangle ABC. It's been dilated, center is O. Maybe, I'm not quite sure what the scale factor is because that's 1, maybe 1.5. But we know corresponding sides are in proportion. And remember, we always are going to be listing the image over the pre-image. This is our image. All of those are in the top of these fractions. And they're all matched up to their corresponding sides. So this means the length from A prime to B prime over the length from A to B. If you divide them, it's going to be the same number as the length of B prime C prime over BC, and it's also going to equal the length from C prime A prime compared to CA, and that all equals your scale factor, that variable K. Corresponding angles are congruent, so that's going to be the exact same as what we did in the last unit. All right, now I want to kind of express this a different way. Oh, actually, no, I don't. That's going to be on the next page. All right, so this is our list. So soon we're going to be doing proofs, and we're going to make that list every time. All right, so let's flip and I'm going to summarize what I just talked about. So dilations create similar figures, and they create, and then there's two characteristics. So dilations create similar figures, and they are the same shape, different size, and here's the two facts. Corresponding angles are congruent. We never multiply an angle measurement by a scale factor. And then corresponding sides are proportional, which means if you compare the image to the pre-image, they will all equal the same scale factor. All right, we looked a little bit at perimeter in another packet and a little bit at area, so we're going to explore that again. There is a link that you could check out. I'm not going to go to that now. You could look at it later if you want. So in this picture, I have a square ABCD, and then I have its image A prime, B prime, C prime, D prime. So it's a dilation. The center is A. So first I want you to think about scale factor. And the grid lines didn't show up very well, so I'm going to be filling in these numbers. There's 5, this is 6. Here's 1, 2, 3, 4, 5, 6. So I am starting with a 2 by 2 square here. This is 2 by 2. And then the bigger one is a 6 by 6. So if you take the image's length divided by the pre-image, we get our scale factor of 3. It's 3 times as big. So I would like you to find the perimeter of ABCD. So you are just adding up all the side lengths. We get a perimeter of 8. All right, let's see now if you can find the perimeter of A prime, B prime, C prime, D prime. They're all side lengths are 6. So perimeter, you add up all your sides, that adds up to 24. Area of a square is length times width, so 2 times 2 gives you 4 for the area of the smaller one. Area of the image, side times side, so 6 times 6, length times width, 36. All right, now I want you to stop and think about something. I want to compare these two perimeters. A way to get from 8 to 24 is to multiply by 3, and you notice 3 is the same as the scale factor. So the perimeter of your larger triangle, which is 3 times as big, is going to be 3 times the perimeter of your pre-image. Let's look at area. How do we go from 4 to 36? Well, we multiply by 9. And do you notice 9 is your scale factor squared? So the area of the image is really our scale factor squared times as big. Area refers to the amount of square units inside a shape. So here's 1 square unit. Here's another. Here's another. Here's a 4th one. A 5th one, 6, 7, 8, 9. It takes 9 squares to fill the image. Area units are always squared, so if you have the area of your pre-image, you have to multiply it by the scale factor squared to get the area of your image. So those facts are summarized down here. Perimeter of your image is the scale factor times the perimeter of the pre-image. So I'm going to do P prime for perimeter of image, and it's K, your scale factor, times the original perimeter. Area of the image is the scale factor squared times the area of the pre-image. So these are important facts. So I'm going to add something to these notes. I'd like you guys to add them on too. Scale factor is K. Right? We know that it's the image over the pre-image. So if I had triangle ABC, and that is similar to triangle A prime, B prime, C prime. I know that that scale factor is our image, A prime, B prime over AB, which is also going to be the same as B prime over C prime, or B prime, C prime divided by BC. If I keep comparing image to pre-image, that all equals the scale factor K. That also equals the perimeter of the image divided by the perimeter of the pre-image. It's the same scale factor. However, for area, if you take the area of the image and divide it by the area of the pre-image, it's going to be your scale factor squared. All right? So all of this is very important too. The length of corresponding images divided by corresponding sides is equal to the scale factor. It's the same relationship with perimeters. The perimeter is going to be so many times as big, but for area, it's the scale factor squared times bigger. Area squared. All right, let's look at example 1. Describe the transformation that maps triangle ABC onto triangle DEF. First thing to identify is which one is the image. If we are mapping a triangle onto another one, triangle DEF is the image. So remember, I want you to circle the image when it's given to you. I want you to highlight it. That's important. So I'm hoping you recognize this is a dilation, same shape, different size. To find the center of dilation, we need to match up correspondence. Point A is going to map up to point D, and an image, pre-image, and the center are always on the same line. So somewhere on that line is the center. I'm going to do another one. I'm going to match up point F and point C. I'm going to connect those just like we did in our notes on constructions. These two intersect at the origin, so our center is the point 0, 0. Now for scale factor, I know it is always the image over the pre-image. I need an image's length. So can we count from F to E? No, that's slanted. How about F to D? Yes, we could count as vertical. We could also count from D to E. I'm going to count from D to E because that is shorter. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units, and then DE, first letter, second letter, compares to side AB. I'm going to count from A to B, 4 units. 10 over 4 reduces to 2.5. So our scale factor is 2.5 times as big. All right, number 2. A triangle is dilated by a scale factor of 3 with center at the origin. So I don't have a picture. I want to know which one's true. I need a picture. So here's my origin. Let's say I have a triangle. It's getting 3 times as big. So it's really important you have that visual. All right, let's see. Is the area of the image 9 times the area of the original? Is the perimeter of the image 9 times the perimeter of the original? Is the slope of any side of the image is 3 times the slope of the corresponding side? Do we ever multiply slopes? That answer is a big no. That one's automatically false. The measure of each angle of the image is 3 times the measure of the corresponding angle. Isn't it true that corresponding angles are congruent? We never multiply angle measurements by a scale factor. It's got to be 1 or 2. So our scale factor was 3. 9 is 3 squared. So which one gets multiplied by the scale factor squared? Is it area or perimeter? Correct answer is area. All right, this video is about to end, so there's going to be a part 2 where I'm going to do problems 3 and 4. All right, bye.